Chain of length L, uniform weight, that is, chain is having a uniform weight, and mass M has 1/4 of a portion hanging here. It is hanging, 1/4 of the chain is hanging. Okay, so L by 4 and its center of mass क्या होगा? L by 8, right? It then starts slipping off the table. At this instant, when it is hanging 1/4, it starts slipping down. Find the kinetic energy chain when it falls off the table. Find when it completely, this point comes here and it is just falling. At that instant, find its kinetic energy. Now we have to apply a work energy theorem in it straight away. Loss in PE is equal to gain in kinetic energy. Mark it as 1 here. Then PE, initial PE क्या है? 3/4 जो what is hanging or lying on the table, so mg into 0, because here it is lying on the table, so we don't consider its potential energy, though it has some potential energy, but we ignore it because it's not hanging. m/4 g L by 8 is the potential energy of the hanging portion, right? Why L by 8? Because the center of gravity is always half of the height. So height is L by 4, so gravity would be L by 8. So this is the potential energy mg h L by 32. P when chain falls off the table is mg L by 2, right? This is h, replace it by L. Okay, so make it L here, make it L. This is not h. And so total change in P is mgl by 2 minus mgl by 32, so it comes to 15 mgl by 32. Initial kinetic energy is 0 because the chain is lying there. So final kinetic energy would be equal to this change in kinetic energy, that is 15 by 32 mgl. This is your answer. This one is your answer. Okay, right? This one is your answer. Fine.